Guys, today we're going to continue with our discussion on risk analysis. In the last session, when we started our discussion on risk analysis, we talked about the severity of consequences and the various levels and what are the definitions for these various levels, as well as we talked about the likelihood of occurrence, as well as the frequency of exposure, and the description of the various categories that defines or characterizes likelihood or probability. We also talked briefly about consequence modeling, and we'll share with you some links and resources where you can get more information and read more about consequence modeling. We shared also with you the risk assessment process and framework and the various kind of tools that can be used in various stages of the risk assessment process. Today, we're going to continue our discussion on risk analysis. I'm going to mention some other tools that are also commonly used in risk assessment. The first one I want to talk about is brainstorming. All right, brainstorming is used a lot in many fields, in all fields, almost in anything. But basically, it's also an approach that can be used to identify hazards in the workplace and analyze the risk in the workplace. And it's actually structured, which means it's based on what checklists, based on some guides or something like that, and it could be unstructured. Now, brainstorming, you have the purpose and scope. That's the first stage. You define what's the purpose of this assessment you're doing, what's the scope of the assessment, what is it supposed to cover in terms of breadth, in terms of depth. That's what you call the scope. And then also you talk about the problem statement, or you pose the problem statement. What is the problem you're trying to look into? What's the problem you want to generate the hazards for or solutions for? Once you've identified or you pose the problem statement, the next is to generate ideas. This is various ways, various approaches, various techniques that may be suitable for carrying out for identifying the risks or suitable to the risk. So we call it this generating various ideas. Then you record these ideas as a result of your brainstorming. You complete the session and finalize your list. So it's a very simple process that simply entails how to develop ideas on risks, okay, and their controls in the workplace. The next one is called the checklist analysis, which is also relatively simple. First of all, you define the scope and purpose of the assessment. Next thing is you carry out or construct a checklist. Now you can select a checklist from what is available in the industry. This might be available in books, might be available in standards, might be available in codes and guidelines. So you usually either you select this one or you try to develop your own checklist, especially if these types of checklists are not readily available. Then you might want to develop your own as well by consulting relevant references. Now also perform checklist analysis. So you perform checklist analysis by going through all the items of the checklist and looking through them one by one in the area of your study. Next is for you to do was to list the hazards and the recommendations. So this is a checklist analysis approach. Here you have what you call the HAZOP, or hazard operability study. Okay, so hazard operability study is used to define the scope and purpose of the risk assessment. And this one you're going to find it in every risk assessment because it's number one step. Okay, scope of findings, and the last step is what? Recording of findings. Here you define responsibilities, assembly of team and assembly of team. Yeah. When you say responsibilities and define responsibilities and assembly team. So define responsibilities for each member. You can conduct or develop what you call responsibility assignment matrix, where you know who is doing what and who's responsible for what. So basically, you carry out the HAZOP with your team members because they're going to basically be involved in brainstorming processes, in developing solutions, and things like that. Then you plan the HAZOP study. Okay, as you create a plan to carry out the HAZOP study. You gather documents, interviews, and observations, and this is a very important step in HAZOP, where it's gather documents. Okay, because you cannot carry out the hazard study if you don't have the documents, the process flow diagrams, the and other various types of documents may be useful for the risk assessment process to understand the entire process and understand the entire system in place. Next, you can break down these components or systems into smaller elements so that each element can be investigated separately. Now, the next step is the design, the green intent of the elements. The design, intent of the elements. So basically, all the various elements in the process, they have their own design intent, which means their purpose, what they're meant to fulfill, and what they're meant to achieve. And once they start deviating away from that purpose, then it means you have a potential risky scenario. So first of all, you can formulate guide words to identify this risky scenario. The guide words could be too much, too less, too hot, too low. You know what I'm saying? So basically, you can have this type of guide words. So if you have a flow of a particular material or chemical, you can say too less flow. If more flow is going to cause problems, or too less flow, right? Or flow in the reverse direction. Okay. So all these are the issues or guide words that you can use that will guide you on hazard risk assessment. The next thing is to do what? Examine elements to identify variations. So if each of the elements you've identified previously, you identify all of them through these guide words. That is using those guide words to evaluate their design intent to know if there's any variation from what is normal. Okay. Once you identify any variations, you move next to identify the causes and consequences of those deviations. All right. What caused those deviations? What could it lead to those deviations? Okay. So you identify causes to that, and then next you identify existing and needed safeguards. Existing means what are the safeguards or existing controls that are used currently in the system. So you can factor that into it as well. And also, what are the future? What do you propose to use? What do you recommend or plan to use? And how does this have any effect on the risk? So you have to analyze all these things and then you present it in the table. So this is a typical flow chart of what we call hazard operability study. Next is the what-if analysis. The what-if analysis is a parametric risk analysis technique that simply asks what-if questions. These what-if questions are meant to prompt brainstorming, okay, to derive feedback for you, to derive information from you. All right, so what-if analysis is a team-based qualitative method used for identifying and analyzing hazards, hazard scenarios, existing controls, and needing additional controls. The primary objective of that is to identify and analyze a system's major hazards and hazard exposure scenarios, causes, deviations, or weaknesses that can lead to hazards, existing controls, and needed controls to achieve an acceptable risk level. So basically, this is a what-if control. It's just like any typical hazard analysis method. Basically, it helps you to identify the hazards, the causes, the controls, and things like that. Now, although it was originally developed for the chemical and petrochemical process industry, what-if and its variations have become widely used in many other industries as well. And this may include energy, this may include manufacturing, high-tech, food processing, transportation, and healthcare, to mention a few. Now, this method can also be applied to a system. That's what-if analysis, okay? Because you're simply asking what-if questions. What-if analysis for the system, for the process, operation, or maintenance. Now, also, it could be at a more specific focus, such as piece of equipment, procedure, or activity. So basically, you could apply what-if analysis at various stages of the process or the system's life cycle. All right. Now, this, like I said, what-if analysis will involve brainstorming sessions where you're going to brainstorm with some of your colleagues, okay, by asking, okay, what if this goes wrong? What if that goes wrong? Then you brainstorm with other members or your team members to come up with possible unwanted or risky scenarios. All right. This will involve cross-functional teams, of course, because to achieve this type of analysis, you're going to need teams with understanding and expertise in various areas related to the process or the system that you are talking about. So you're going to have cross-functional teams that are knowledgeable of the process, discuss aspects in a random, creative fashion, asking what-if questions. So these cross-functional teams will have to sit together and brainstorm while they keep asking themselves, what if this go wrong? What if this happens? What if this happens? Okay. So they ask these questions to identify any weaknesses, deviations, or hazards in the system. And that's why I say what-if analysis is more or less a parametric risk analysis method, because they keep asking questions, what if this goes wrong? What if this goes wrong? And there can be no end to the hazards that may be identified through what-if analysis. Now you can document all your findings in a spreadsheet format or in a tabular format, where you have all the tasks or elements of the system, and the post what-if questions that you've asked for these various elements, along with resulting consequences. What are the consequences of any hazards that may result from it? Existing safeguards and recommended additional controls. So here is also a flow chart here showing the what-if analysis and how it moves all the way from assembling the team down to reporting the findings of the assessment. So you can see when what-if flow chart here, we have document review, that's the first step. Okay, and what are the steps that you can take in document review? This is number one. So here, define the scope, the purpose and the scope, review the process document, manufacturer information. Okay, so you review all this information. And this is, by the way, not only for what-if analysis. If you want to carry out any risk analysis, it's advisable that once, after you define the purpose and the scope, that you do some review of existing literature, documents, data, manufacturers' information, research, and applicable standards, incident or past accident records in your organization, and then you can develop all various hazard scenarios. So this step here is very good and a very nice step for other risk assessment methods as well. So I'm saying applicable to other risk assessment or risk management methods. All right. Now, next is what physical observation of the site. You go on site to carry out physical observations, okay, or what is happening on the site to understand the risks better. So you have online technical walkthrough of the system, observe and collect data, develop hazard scenarios. Then you have team analysis, team workshop. Okay, that's the place you come together to discuss with all your teams, then brainstorm hazard scenarios. So basically, you come together to discuss and to think about various hazard scenarios, what could go wrong and what the causes and the consequences. We analyze the causes, analyze existing safeguards, identify potential guard or weakness, and then identify needs or standards. Okay, identify needs of safeguards. Sorry, identify the needs of the safeguards. The last stage is to report your findings. Okay, here you compile and review results of the analysis, complete what-if document, and report. Okay, so this is an example of what-if analysis, as I explained to you previously. We have what if, for example, this is the hazard. What if methanol tanks, trim, and piping are incompatible? Okay, they're not fitting one another. We have corrosion from incompatible materials and proximity to the ocean, fluoride salt, overpressure, rupture, and fire and explosion. We could have PM schedule and inspections. This could be the current controls that is being put in place. And then your recommended control could be replace trimming and piping with compatible materials, carry out cathodic protection for corrosion and things like that. Okay, so you can see here it lists first of all what could go wrong, what could influence the system or a potentially risky scenario, what could be the causes, the consequences, what are the current controls, and what are any future or recommended controls that you may have. Okay. This is another example of difference between what if and structured what if. For structured what if here, okay, similar to the what if analysis, except that it had some few more elements like formulate questions, break down into tasks and elements, and perform checklist for review for checklist review for additional comments. All right. So we call this structured what if because it follows a more structured approach because it provides more steps to follow in the what if analysis, but it's very similar to the previous what if analysis which we already discussed. Here's another example here of an example of a structured what if analysis. You can see it's similar to what if analysis. So you have what if insufficient purging of flare system. What could be the consequences? You have inadequate or purge gas used, at least 10 systems, 10 system volumes or to top or to level below. Yeah, so these are basically causes. Yeah, some of these causes, because you might not be an expert or a specialist in that specific area, your team members should have members that are expert that have expertise, right, in the area that you're talking about. If you look at the team members up here, you have Bruce Lyon, who is the author of the book we are using. He's a facilitator, right, which is the risk analyst or the HSE engineer or the safety engineer like you. We have one person called fire protection specialist. Okay, so they're looking at fire protection because there will be a risk of fire. Okay, you have engineering specialist here. Okay, we may have to do with other engineering issues like basic engineering of physics or maths, where you have to consider the materials and things like that. Then you have someone that's responsible for safety and health, okay, for people and property. You have someone responsible for the environment, maintenance, and production and tax or / tank car cleaning. Okay, so you have that's some probably involved also in maintenance. So you have these various groups of people. They might even tell, okay, it's possible that this folk should go wrong, and they might also brainstorm and look at what are the causes, what could lead to that. Right. Once they've done that, then you can identify the consequences of that. You know the causes now. You determine the consequences, and based on that, you can determine what potential controls you can use. And after that, you brainstorm on what recommendations that you want to include after the existing controls. So I want us to stop here at what if hazard analysis because I have an assignment, like I told you guys, I'm going to post in the Blackboard, all right, on what if analysis as well as hazard. All right. So we'll stop here so that next time we can start a new discussion on preliminary hazard analysis. So in that case,